Hi everybody, my name is Manuel and I'm co-founder of Emiria, an indie studio developing VR games and interactive installations. With this video I'm also launching Diffluctum, which is dedicated to animation films. In this tutorial we are going to have a look on how to design this organic building design, starting from its general shape and form and keeping everything procedural in the process. Then we are moving on in designing the windows, projecting them back onto the facade and extruding them with some variation. If this tutorial is useful for you, please subscribe and follow me on social media. It would help me a lot and you would not miss the upcoming videos. That being said, let's get ready. We start as always with a GeoNode, dive in, and first we start by creating the general floor plan of the building. For this we simply use a grid and we cut out a cube using a Boolean subtract node. Plug the grid into the first input of the Boolean node and the cube into the second one. Because we are cutting out from a single plane, we have to set the first input to surface. Change the shape of the grid and the cube to something like this. Now let's copy the floors as outlines to create our outer shape. To extract the outer edges, we can use a group node. Set it to edges and disable base group. Down here, enable also include by edges and unshared edges. With a convert line node, we extract the lines. Select the just create group and select connect path as well as delete unused points. With this, we have one primitive instead of multiple primitives per segment. To further clean the curve, we add a remove inline points node, which is technically a facet node with some parameters already set in order to have a shortcut. After this, let's copy the line. Something like this works well for now, and create a group from them, which will be useful later on. The group type is primitives, and let's call it main floors. Further, we also create two other groups, the roof and the floor. This can be done manually, but let's keep it procedurally and use a group expression node. In here, let's add two expressions. One for the group called roof, and here we want to select the last primitive, which in our case is a primitive with the number 4. So therefore we say it should create a group if the primitive number at primnum equals, here make sure to have two equal signs, to the total number of primitives at numprim minus 1. We do minus 1 because the numbering starts always from 0, which means if we have 5 primitives, we would have a primitive with a numbering from 0 to 4. And the second group we call floor. Here we need a corresponding prim number 0. Writing at primnum equals 0. Great. Now, in order to subdivide our main floor lines further, we use again a copy node. But we see here that we also copied the last curve as well, which is our roof. In order to exclude it, we can use an expression in the group source by typing exclamation mark, which basically excludes things like groups, and the name of our group, which in our case is roof. Then, in order to have an equal subdivision between the lines, we need the distance between the floors divided by the amount of subdivisions. Coming up here in our previous copy node, we right-click in the corresponding parameter and select Copy Parameter. Then in our new copy node, we right-click again and select Paste Relative References. This now links the value from above into here. Then we type divide and reference in the same way the total number of subdivisions. By left mouse clicking into the parameter, we can switch between the expression referencing the parameters and the actual value it outputs. This allows us to keep everything connected, meaning when we change the amount of floors or the floor height, it updates automatically. We also add here another group node, and this time we create a name for the floor subdivision. When we are displaying the primitive number in the viewport, we see that our prim numbers are not ordered properly. To fix this, we can use a sort node. Here we need to go into the primitive section and select sort by Y, This reorders now the primitive numbers from the bottom to the top. Perfect, let's conclude this step with a null node. Our next step is to form the shape of the facade, to make it more organic and smooth. We start here by adding some horizontal variations. For this, we will offset the floor lines with an extrude node. In here, our extrusion mode is primitives and edge normals, and then down here, disable output sides to offset only the curves without creating a surface. Also, the extrude node allows us to use an attribute for the distance. Let's declare this already. I call this facade offset. In order to create this attribute and the pattern we want to have on the facade, we can use a primitive VOP node. Dive inside the node, and here we start now by creating the offset attribute first. Here use a bind export node, and the name of the attribute is the one we just created outside, called facade offset. When we add a constant node to test the offset, we see that we are indeed outputting the attribute, but it's not affecting our extrude node. This is because the extrude node reads point attributes, and our facade offset attribute is currently a primitive attribute. To fix this, we use an attribute promote node to promote the attributes from primitives to points. Now we see immediately that the offset takes effect. Also, to always keep in mind is that the attribute value is multiplied by the distance value in our extrude node. And in our case, we want to offset the lines inwards, and therefore we set it to -1. To now move on, keep the display flag on the extrude node and come back inside the VOP node. First, we need to create a normalized value from 0 to 1 along our floor lines. We take therefore the primitive number, which is the number of each individual floor line, and convert it from an integer to a float. The same we will also do for the number of primitives, which is the numprim attribute here. Because the prim numbers start counting from 0, as we know, we need to subtract 1, and for this we use a subtract constant node. Next we use a fit node, where we remap the primitive number in between 0 and the total number of primitives into 0 and 1, and connect it to the bind export node, which is then exactly what we need to create our spline ramp. After this we add a ramp node and set the type to spline, also give it a name and a label. Afterwards the ramp gets exposed onto the VOP node itself, meaning that changes here inside on the ramp will have no effect. You have to jump back out and use the ramp here on the VOP node itself. Here you can find further interpolation settings, like Bezier curve interpolation, giving you extra control. I prefer to have them as B-splines, and you can play around until you find something you like. So now these leftover points we can remove them with an add node. Come here to the polygons tab and select remove unused points. We are now moving on to round the corners of our facade. First we use a polypath node to prepare our curves, and here select make isolated loops closed. Having now surfaces, we can round the corners with a polybevel node. Set the group type to points and increase the subdivisions. In the same approach like with the offset, we add some variety to it by using an attribute for the radius. Here next to the distance parameter, we can select scale by attribute. Here in the point offset scale, we can declare the name of our attribute. In my case, I call it B-scale. The first idea is to make the radius dependent on the length of each wall. For example, corners connected by longer walls should get a larger radius. In order to do this, we need first to measure the length of each wall segment. Drop down our convert line node. This node splits our curves into individual primitives per segment, and also it can compute the rest length by selecting here compute length. This now creates a length attribute for each segment as a primitive attribute. Then now we need to promote this primitive attribute into a point attribute. For this we use an attribute promote node. Select here from primitives to points, and then we select the rest length attribute. Also we automatically rename it to p-scale, which is the attribute we need. Then as next we use the attribute normalize node to normalize our p-scale from 0 to 1. Coming into the normalize node, First thing, we select our just created attribute bscale, and then we can also use a curve to remap the value. We can now further adjust the curve to our liking till we find a good result, as well as change the values in the polybevel node. Something like this works good for me. As further detail, we can also add a noise value to it. For this, I like to simply use an attribute adjust float node. The attribute name I want to change is bscale, and we want to multiply the noise value with our existing values. Select the pattern type as noise, and the range to multiply is for me between almost half the size and around 1.3 times the actual size. Play around with the noise patterns till you find something what you like. Something like this works fine for me. We conclude by converting the planes back to curves. For this I use simply a convert line node, and I also select connect path to have only single connected polygons. Also, we can deselect to compute length as we don't need it in this case. As last layer to our facade, we are going to add another overall noise distortion. For this, we are going first to resample the lines to have a better resolution for the noise pattern. Inside the resample node, select resample by polygon edge and change the length value to something like this. Then we can also clean the curves with another fuse node. For our noise distortion, we need first to create a directional vector which is pointing outwards, normal from the curve. This we are going to do in 2 steps. First, we evaluate the tangent vector along the curve. Then we are going to calculate a vector up and the cross product from both, the tangent vector and the vector up, in order to create the resulting normal vector we need. We start by generating the tangent vector. For this we use a polyframe node. In here, we only need the tangent name, which we leave as default, and by opening the node info, we can enable the visualizer for the tangents. Coming in here, we can also increase the size of the vector visualizer, and this seems correct. Our normal vector we are going to calculate using a point wrangle node. First, we create a vector up, writing vector up equals set, and then in columns 0, 1 and 0. And then we create a normal vector resulting from the cross product between our tangent and the up vector, writing at n for our normal vector equals cross for the cross product function, and in columns we take our tangent vector and the vector up. Also, we normalize the result by writing normalize in front and put everything in columns. Great, we have now the normal vector for our offset direction. Creating the noise itself, we again use a point VOP node. Dive in, and here we use an anti-alias flow noise for the noise pattern. As input we need the position, and the output we multiply by the normal vector. This results in normal vectors with different lengths based on the noise pattern, and we're going to add this back to our position. And this new result gets outputted as P. Usually the settings I need are the frequency, which I will dial down, as well as the offset, amplitude, and the roughness. The roughness I set down to 0 to have a smooth noise pattern. Also, I want that the noise offset is less towards the bottom and more towards the upper part of the facade. Therefore, we need to create a multiplier based on the height values of the points. We can extract the height values from the position attribute with a vector to float. And then we remap the y value, which corresponds to the height, with a fit node. We can see now that when we change the input range, the offset value adapts, meaning every point lower than the min value has no offset. Every point above the max value has the full effect, and the range in between fades between 0 and 1. Additionally, we also add a softer noise to the height of the lines as well. Again, I use an anti-alias flow noise, plug in the position, and I add the result to the extracted y value of the points. Then we recreate the position vector with our noise effect by using a float to vector node. and replace the position value in the Add node. Also here I play around with the frequency, the amplitude, and I set the roughness to 0. Also, to not forget, we are going to multiply this new vertical noise also with our bottom-up fade effect, to have also here less noise on the bottom area and more on the top. Change the noise values and further design parameters till you reach a good result you like. Something like this works fine for me. As last step here for our lines, we use again a resample node to clean out the curves. Now let's create an actual mesh out of this. We use a polyloft node to create a surface mesh. We can leave the settings as default and then we can clean the mesh with the quadri-mesh node. Here I played around with the decimation and adaptivity settings till I reach a clean topology. Keep in mind that this node is still in beta and maybe in the future it might look a bit different for you. So we conclude this step with a reverse and a normal node to get a clean outwards facing surface. Next we create the roof. Start by grouping the open edges of the mesh with a group node. Set it to edges, disable base group, and enable include edges and unshared edges. With a polyfill node, we can select our just created group and fill it with a single polygon. Also select down here the output group for the patch. Next we use a delete node to delete the facade and to have only the roof and floor left. We need to select our patch group and delete non-selected. Also we are going to clean the wrong shading with a normal node. Setting this to primitive normals will do the trick. For the next step, we will isolate the roof surface. To do this procedurally, we can simply use a delete node and use the vector direction as a parameter to delete the corresponding face. We keep the entity as primitives, and coming to the normal tab, we delete by the normal vector up, which corresponds to 0, 1, 0. The spread angle threshold we can dial down to 90 degrees and select delete non-selected. We should be left now with the roof surface only. Now we add a profile to the roof border with an extrude node. Deselect here output front and play around with the distance and inset values. Also enable the front boundary group, which we will need later. Adding the template flag to the facade mesh, we can adjust the profile to our liking. To something like this. To now insert a border, we need first to create a normal vector pointing inwards. We use a normal node, set it to points, and we can now flatten this value in the y-axis with a wrangle node. Here inside the vex code we write @n for our normal vector and equals set, and in columns we keep the normal x value at n.x. For the y value we set it to 0, and for the z value we keep the normal value as well, which is at n.z. Having this new normal vector, we can now insert the border with another polyextrude node. But this time we select our previously created group, which is called extrude front seam. Also, we are going to use the point normal as extrusion direction, and instead of pre-calculating it from the extrude node, we use our just created existing one. Insert it to something like this. And output here again the front boundary group, but this time give it another name, to not have overlapping attributes. Now we add another polyextrude node to extrude it downwards again. We come here and select our just created group, as well as extrude mode to point normal. And for the distance, we use the same amount we previously extruded upwards. Coming back to the first polyextrude node, we go here and right-click into the distance parameter and copy references. Then back here in our new polyextrude node, we right-click and paste relative references. Also here add multiplied by -1 to reverse the direction. Examining our mesh, we see that inwards turning edges have some overlappings. but we can simply correct them with a fuse node. Dial here the value up till all points are merged together. Now to conclude, we merge it back to the roof and floor surface. Also clean it by adding a group delete and the attribute delete node. As well as a normal node to repair the normals. In here, we select primitives and add a null node to conclude this step. Next, we are going to separate the bottom surface as well. For this, simply copy the delete node by clicking Alt and dragging the node. And here, select delete selected to invert the selection. So I add a null node as well and name it accordingly. And also we do the same for the general facade mesh. Now we are going to create a tiling of the facade. For the tiling of the facade, we need first to come back to the floor lines we had earlier and use a group range to select every third curve. In the range filter of the group node, select one of three. Also, we want to deselect the first curve, which is on the bottom, and we can do this with another group range node. Here this time set start and end to 1 and select invert selection. And then we can simply use subtract from existing to remove them from the previous selection. Then we duplicate a node, and this time instead of subtract, we use union with existing. Then on both sides, we go on to delete the non-selected curves with a delete node. So the curves without the top and bottom are our horizontal pattern lines, and with the other ones, we create the vertical tiling lines. Use a for each connected prim loop to iterate over each curve. Then inside the loop, move on by resampling the curves with a fixed number. Select here maximum segments and deselect maximum segment length. In my case, a value of 320 works well. Then again, we use a group range node so that we can select points within our desired pattern. Set the group type to points and name it something like grid points. So for me, selecting every 10th point looks great, but you can play around with this value as well. Further, we use an enumerate node to create an ID value, which will correspond to the point number. The attribute we call ID, and make sure to have the type set to points. Using this within the for each loop allows us to have the same ID values for each curve individually, storing the numbers from 0 to 320. Notice that after the for each loop, where all curves are combined back together, the point number goes beyond 320 because it always represents the actual number of points in the geometry, whereas our ID values state for each curve from 0 to 320. Now we can delete the points, except our grouped ones, with a delete node. Set it to points, then select the group, and we delete the non-selected. In order to delete a curve but keep the points, we can use an add node. Here inside, simply select delete geometry but keep points. Also use a fuse node to remove overlapping double points. Now the ID attribute we created comes in use. When visualizing the values, we can see that the corresponding points we want to connect as a vertical line have the same ID values. Using an add node, we can connect these points with the same ID with a curve. Go into the polygon step and then we connect by group. Here we want to add connections based on an attribute. And the attribute we are going to use is called ID. This looks great. Let's merge it back with our horizontal lines. Because these lines are not corresponding exactly to our surface, we are going to project them back onto it again. But first, we resample the curve a bit further, so that we have a better approximation to the surface. In here, in the resample node, I set it to 0.3 to increase the division, and then I smooth it by selecting subdivision curve. This looks already better, and now we can move on by projecting the curves back onto the surface with a ray node. In the first input, we connect the lines, and in the second one, our facade surface. In here, we select as projection method minimum distance. This will project each point of our curves to the closest position on the surface. The result we clean with a fuse node to have no double points and a resample node. Now that we have our grid, we are going to cut the facade surface based on these lines and create a spacing between each of these. Our first step is to extrude the curve to become surfaces, and the extrusion direction should go normal to the facade. Meaning before that, we need to transfer the normal attribute from the facade onto the curves. For this, we generate a point normal on the facade geometry with a normal node, set it to points, and then we use the attribute transfer node to transfer these facade normals onto our curve points. Here select the point attribute n, which corresponds to our normals, and then in the condition step, we increase the sample size to 100 to get a better interpolation. Further, again, we have to make all the vectors aligned horizontally, so that they are not pointing tilted anymore. We use here again a point wrangle, and simply write at n for the normals equals set, and in columns the x value stays the same, so at n point x. Then for the y value we use 0, because we want them to have all aligned horizontally. And then for the z value, again the normal value, at n point z. Then let's add a smooth node to smooth the normals out a little bit to have a better result. For the attributes to smooth, we use n, and we play with the strength and filter quality till they align better. Great, we have now the extrude direction ready, and with another extrude node we can extrude the curves in order to maintain a surface. As method we use the point normals, which we just set up, so therefore select existing, and as distance, something like this works well for me. Also we extrude to the other side as well by cloning the node with all its parameters linked. For this, simply hold Ctrl, Shift and Alt and drag the node. By doing this, you create a completely referenced copy of the same node. This is very useful to maintain same values through multiple node streams. By clicking into the property, we see the reference path. Here we can simply add multiply -1 to invert the extrusion direction. With a merge node, we can bring both together, and now we have an extrusion of both sides. In addition, we use a fuse node to connect both surfaces together, and a normal node to clean the shading. Something important here, before we move on, is to check the direction of the mesh faces. By displaying back faces, we can see that both values of the surfaces are of opposite direction. We can flip one of them by dropping a reverse node and connect it after the second extrude node to flip the face direction. So now everything should be correct. In order to create a closed volume, we extrude the meshes again by repeating the same method. This time we leave the settings as default, and as distance I use a very small value to get a very thin cut into the facade. A value of 0.005 worked fine for me. Again, reference duplicate the node by holding Ctrl Shift Alt and drag the node. And in the distance parameter we add again multiplied -1 to reverse the extrusion. We can copy the node structure from above with the reverse merge and cleaning setup and use it here as well. As last step, we are now going to cut out the spacings from the facade with a Boolean node. In the first input, we connect the facade mesh, and in the second, our grid mesh. Don't forget, our facade is a surface, and solid for input B is correct. And as operation, we use subtract. This looks great. Now we can move on working with the windows. Thanks a lot for watching. If you liked the video, please give it a thumbs up and subscribe to my channel. It would help a lot. And see you in the next one.